get from the graph. So there are three types of graphs, just quickly again. The first graph is a displacement versus time graph. The second graph is a velocity versus time graph. And the third one is an acceleration versus time graph, yes. So not just in kinematics, in everything in science, there's always two things that you can possibly use, and that's the area or the gradient. And if you forget, please don't think it's only for motion. Always go and think, if they give you a graph, ask yourself, does the area give me something? Does the gradient give me something? And you're always going to do that. We will post a picture for all of you that we took of this. So you don't have to worry about writing it down. Okay, so if for the first one, the area you always know is going to be side times side. So it's x times y. If you're thinking about a graph that this is y and this is x, so it's x times y. So this is going to be, remember the unit for this is meters, seconds. I'm going to go fast because we've done this before. This is meters per second, and this is seconds. This is meters per second squared, and this is seconds. Stop me if I'm going too fast, but I'm assuming you've all done this. So if we go and say area, it's always side times side, length times breadth, half base times height, but it's always side times side. So it's meters times by seconds. That's the area. The gradient is always y over x. So that's going to be meters divided by seconds. So you can see for yourself now that this gives me nothing. I can do nothing with meters times by second, but I can do something with meters per second. That is going to give me the velocity or the speed if it's in a straight line. Then, so you don't have to go and, you can go and learn it, but if you forget in an exam stress, I always say, makes your brain go all weird. Here, area again is x times y, gradient is y divided by x, so here it's going to be meters per second already, and now we're going to say let's times that by seconds, which means it's a plus 1 and minus 1 cancel each other, we end up with meters. For this one, it's meters per second again, divided by seconds. Oh, that's not a minus plus 1 at the bottom of the line, but it goes up and it becomes meters per second squared. So you can see that this time there are two things. We do have something that we measure in meters. What is that? Yes, so this is going to be displacement or distance. Do we have something that we measure in meters per second squared? Acceleration. So yes, and that is why you will see this graph is the one that is most often asked, because we can use it to get the displacement by getting the area, or we can use it to get the acceleration by getting the gradient. Then for the last one, for the area here, it's again x times y, and here it's again y divided by x, the gradient. Now this time for the area, it's meters per second squared times by seconds. That's a plus 1. So the plus 1 cancels one of those and we end up with meters per second. I'm assuming your maths is amazing because you're taking science. And this is meters per second squared over seconds, which becomes meters per second to the minus 3. Is there anything that we measure in meters per second to the minus 3? No, but yes, we do have meters per second, and again, that is going to give us the velocity. Okay, so if you forget, always just go and check that. So when you get a graph, like the one we just have here, the first thing you're going to do is say, what graph do I have? What can I use? So that's always your first step. So if we look at this graph, what graph do I have? Velocity time graph. As soon as you told yourself that it's a velocity time graph, before you even look at the questions, guys, because that is going to confuse you, just immediately say to yourself what you can use Write it down because you're going to use it at some point, so it's never a waste of time. Gradient and area. If it's a velocity time graph, what does the gradient give me?
It gives you.
It is a velocity time graph. What is the gradient?
It gives you speed or velocity.
Guys, I'm going to say it again. Okay, let's go back here. Guys, it's this graph. It's a velocity time graph. The gradient is meters per second divided by seconds. Can you see why? In an exam, you think you've memorized it. And it's happened to most of you here, where you now forgot already. And I just said it 5 seconds ago. Gradient is meters per second over second. So it's meters per second squared. So it's the acceleration. Please, that is the most important thing. Gradient gives us the acceleration. What does the area give me? That gives me the displacement. So that, can you see why it's important to go and write that down before you even start with the question? Because if you jump into the question, you get confused. Don't let that, and in an exam, it's worse. Then the next thing that you do before you start answering the question is you know there's a velocity time graph. So here all the velocities are positive. So write for yourself here. Positive velocities are here, and the question told us that it's starting at 8 meters per second north. So anything above the line would be north. So what will anything below the line? This is what, when I say anything, I mean velocities, because it's a velocity graph. So velocities above the graph is north, velocities below the graph is their negative, and it will be south. Once you've done those two things quick, gradient, area, north and south, then you start looking at the questions. Now we're going to say, if the gradient of the graph between t equals 0 and t equals 5 is minus 4, 0,4, calculate the value of v. So they've changed it around a bit. But don't get confused by it. Just trust your training, guys, always. Because they're telling you what the gradient is. So they're telling you the gradient is equal to minus 0,4. You know the gradient is change in y over change in x, right? Is equal to 0,4. And they're asking you what the velocity is there. So now we're going to say, okay, if it's for the first 5 seconds, you are allowed in science to use a highlighter or colored pencils. They're looking for that little bit there. So for this question, we're looking for that little bit there. So we're going to say, yeah?
Do you have to drop the minus?
No, you definitely must not. If they give it you as a minus, you need to keep a minus. Yes. Sorry, that was a mistake. So we're going to say final minus initial. So it's always for a change, it's final minus initial. So it's V naught is the one that they're asking us, or that V that they're asking us for. I'm just calling it V naught because it looks like a naught there. Minus, that's our value, minus 8. Always the last one minus the first one. Then the times is 5 minus 0. And this is equal to minus 0,4. Now you already have all the science marks. The science marks are for realizing that the gradient is 0,4, that the gradient is change in y. They didn't actually have to tell you that it is the gradient. What would we do actually in next week's test? Well, we tell you that it's the gradient that is minus 0,4. Yes, we would say the acceleration is 0,4, that you need to realize that the gradient is equal to the acceleration. That's what we will do in a test. Now the rest is algebra. All you have to do is say, fine, I know these values now. So we can do the algebra. Remember, that goes first. Or you can just do it on your calculator. We don't give you any other marks. I was talking about the marks. 1 mark for that, 1 mark for that. 1 mark for substitution. And then you only get 1 mark for the answer. So the maths from here to the answer that says V equals, it's only worth 1 mark. So your calculator job gets 1 mark only. Yes.
So ma'am, I just wanted to ask, isn't changing y over x and gradient the same thing?
Yes.
So ma'am, writing that size gives you 2 marks.
No.
Like ma'am, gradient.
If there was an we told you that it's the acceleration, then that would give you another mark.
Okay.
So he is right. We won't give you 2 marks for saying the same thing. All right, but now the calculator work gives you 1 mark.
Now, isn't we already 8 there?